Welcome back. Now let's continue with the chemical properties of nitrogen. Originally, nitrogen is not that reactive because it has a very strong covalent bond. So if you look at the structure of nitrogen, you have N and 3. So it has about 3 covalent bonds which needs to be broken before it becomes reactive. So that is why it's not reactive at a low temperature or pressure. So for it to become reactive, you increase the temperature and the pressure. So at high temperature and pressure, nitrogen can combine with reactive metals, electropositive metals. For example, A, reaction with metal. It can react with magnesium. When it reacts with magnesium, it forms magnesium nitride in the reaction as seen below. So you have magnesium, Mg, plus nitrogen, which is a gas. So this is heat, because it has to be at a high temperature. Okay, so now the product form will now be Mg3N2. So this is a solid. So this only occurs at a high temperature and pressure. Then with hydrogen, nitrogen also reacts with hydrogen at high temperature and pressure and in the presence of some catalysts such as iron. If it does that, ammonia is formed. Let's see the reaction. So you have your nitrogen, which is a gas. You have your hydrogen, which is also a gas. So here is the arrow like we know. So you apply heat, which is high temperature and pressure. Then there's catalyst too to speed it up. So when these two react, you're going to get ammonia, NH3. So when we balance it, we have this, which is also a gas. These reactions are only possible again when there's high temperature and pressure. Then nitrogen can also combine with oxygen. And it does that, nitrogen 2 oxide is formed. So you have N2 plus O2. So they are both gases. So we now have NO2NO, which is a gas. These are just few of the reactions that nitrogen can undergo since it's not very reactive at low temperature and pressure. Now the uses. What do we use nitrogen for? Well, if you remember one of the separating technique, chromatography, we have the gas chromatography. Now in gas chromatography, nitrogen can be used as a carrier gas because in gas chromatography we have the mobile and stationary phase. So this mobile phase, nitrogen can be used as the phase that carries the particles that want to be separated. Then apart from that, nitrogen is used to produce vital and important chemicals, fertilizers. Even in the production of triazonitrate 5, nitrogen is a starting material. Cyanide, nitrogen is starting material. Nitrogen can also be used as a cooling agent. Liquefied nitrogen, when the temperature is reduced, it cools any object around it. So these are some of the chemical properties of uses of nitrogen. Now let's quickly look at nitrogen cycle. Nitrogen cycle has to do with the conversion and circulation of atmospheric nitrogen to the combined nitrogen in the earth crust. What we are saying is the nitrogen in the atmosphere can be converted to the nitrogen in plants and animals. Talking about the nitrogenous part of the tissues, the nitrogen in the tissues of plant and animal. So the conversion of the atmospheric to the soil nitrogen and soil nitrogen to atmospheric gives us a cycle. So we now have something like this. From the atmosphere, we go to the soil. So it's the soil nitrogen. Then from soil nitrogen back to atmospheric nitrogen. So this conversion is what we call the nitrogen cycle. Now from atmospheric nitrogen to soil nitrogen is called nitrogen fixation. When we are converting atmospheric nitrogen to soil nitrogen, we are actually fixing the atmospheric nitrogen, converting it. Then taking it back from soil nitrogen to atmospheric is called denitrification. So it's just a Bas-Basel process. Now in fixing of atmospheric nitrogen to soil nitrogen, some bacteria present in the nodules and roots of some plants can do that. One of such bacteria is your rhizobium.